In today's video, we will be discussing Physics 251, Week 5, Video Explainer, problem number 56. In this problem, we're asked some questions pertaining to force and motion. We're asked to draw some free body diagrams as well as some pictures to kind of illustrate what is going on when we feel like we're kind of jolted forward when a car is slowing down or stopping. So this kind of really relates to Newton's first law of motion, and this is all this information is seen in the week 5 lecture under kind of page 7 to 12 is what I found to be helpful. So if you have any questions throughout the video, I would recommend going back to that and taking a look. All right, so let's get into the problem. So I've kind of underlined some of the givens here. It's important to note that we're sitting on a very slippery box in this problem, which implies that there is no friction um, as well as no seat back. So for this initial problem, we have our passenger right here, and they are traveling at a constant speed. So when they are traveling at a constant speed forward, there is going to be no net force acting on them. We also don't know which direction that um, that the car is traveling in. We can assume that it's traveling in the positive direction. That's why I drew him facing forward, but the problem does not specify, so therefore we do not know. Um, so we have our steady speed forward, constant velocity. We have these two forces acting on them. So we have the normal force pointing upward, as we can see in the free body diagram, as well as the force of gravity pointing downward. And we have no net force direction because the sum of the forces in the y direction equals 0. And there is no force acting in the x direction, so therefore it is 0 as well. All right, for C, here we have the car is slowing down. So since we're sitting on a very slippery box with no friction, we need to kind of assume what would happen if the car's velocity is different from that of our passenger. So in this situation, I have drawn what happens when the passenger kind of slides off of the box because the passenger is moving at the same constant velocity because there is no forces acting on them to slow them down. So up until the point where the passenger leaves the box, they are exhibiting both normal and gravitational forces. But as soon as they come off of that box, they're acting as a projectile, and their net force is going to be downwards, just the force of gravity. So as we can see here, force of gravity, and he's just flying off of that seat. All right, so for part D, E, and F, I've kind of outlined uh, kind of done some write-ups. If you want to take a look at those, they go into a little more depth, but I'm just going to briefly explain what each of them says. So as I mentioned, we're kind of acting as a projectile, transitioning from normal force and force of gravity to just force of gravity. And our passenger is continuing in a constant velocity in the x direction, and it does not change as they slide off of the box. For part E, this is really pertaining to Newton's first law, where an object at rest will remain at rest and an object in motion will remain in motion. Since there are no forces acting on our passenger to slow them down, they are just going to keep going forward off of that slippery seat. And the reason they feel that they are thrown forward is because of their reference frame. So since the car and the passenger are moving at different velocities, the passenger kind of has the idea that they're getting jolted forward. For part F, if we assume that our bench is exhibiting the frictional force is what's going to keep our passenger in the chair. And this force will act in the opposite direction of whatever their velocity vector is, or the direction of the car's motion. I hope you guys found this video helpful. I also got to mention the net force is going to be opposite the velocity. So, all right. Well, thank you very much for watching.